Hello, my name is Grant Kim, and this is my Physics 2212 Lab 1 presentation. So first, we're going to introduce some basic fundamentals and principles that we need to understand before we get into this experiment. So the objectives of this lab are to prepare charged pieces of tape and then use the pieces of tape to observe charges moving between the surfaces. Then, we can determine the excess charge on a single piece of tape. There are a few fundamental equations that we need to understand before we get into this experiment. The first fundamental equation is Newton's second law, which is force equals mass times acceleration. The second fundamental equation is Coulomb's law, which is force equals Coulomb's constant times the 2-point charges divided by the distance squared. Some important values that we need to keep in mind are the gravity constant, which is negative 9.81 meters per second squared, the K constant, which is 9 times 10 to the 9 Newton meters squared per column, the size of an electron, which is roughly 1.6 times 10 to the negative 19 meters, and the average length of an atom, which is roughly 1 times 10 to the negative 10 meters. Here's a preview of the results from this lab. Charged pieces of tape repel each other because they are positively charged. The charge on each piece of tape is roughly 1.27566 times 10 to the negative 8 coulombs, and the deficiency of electrons on each piece of tape is roughly 7.9729 times 10 to the 10. And now that we have that covered, we can get into the actual experiments themselves. For this experiment, we need a few materials. We need one roll of clear tape, a ruler, a flat surface, and 2 thick books or other stackable objects for support. We also need to make some assumptions before we get into the experiments. We need to assume that air resistance is negligible, that each U-tape has the same net charge, I'll get into why that is later. Each long tape is treated as though it were a point charge, with all the charge concentrated at the center of the long tape, and assume that each U-tape made has about the same amount of charge evenly distributed along the length of the tape. So the first experiment is simple. We just want to create charged tapes and observe some basic interactions between them. The starting conditions are that tapes A, B, and C, 3 different pieces of tape, are placed stacked on top of each other on the table. The system for this experiment is tape A, while the environment is tape B and C and the rest of the room. Going into this experiment, the expectations are that U-tapes will repel each other and have the same charge, and that U-tapes will be attracted to neutral objects because they are charged. The results are that the U-tapes did indeed repel each other, and that the U-tape was attracted to the neutral hand, the negatively charged plastic pen, and the neutrally charged metal bottle. Thus, we can assume that the hanging U-tape is positively charged. The second experiment is to determine the exact amount of charge on one U-tape. The starting conditions are that we have 2 pieces of tape that are about 0.211 meters long. Each piece of tape has a mass of about 0.000211 kilograms, and the tape width is about 0.020 meters. Tape B is suspended between the 2 objects, while tape A is held in the hands. The system is tape A and B, while the environment is the rest of the room. The expectations are that the U-tapes will repel each other and that tape B will float. And this was indeed the case. U-tape B floated up about a distance of 0.0266 meters. And now we need to conduct some calculations for this experiment. The first one we'll conduct is to find the gravitational force on U-tape B when it is at rest. We can do this by using Newton's second law and multiplying the mass of the tape by the gravitational constant to get the value shown on screen. The second equation we'll conduct is to find the electrical force of the tape. Since the tape is not experiencing momentum, this value is equal to the absolute value of the gravitational force. Now that we have the electrical force of U-tape B, we can use it to find the charge. Using Coulomb's law, we get the value shown on screen. To find the actual number of electrons on the tape, we can divide the charge by the size of an electron to get the value shown on the screen. To find the number of atoms, we can take the tape length, multiply it by the tape width, and divide that by the length of an atom squared. And finally, to get the ratio of atoms to electrons, we can simply divide the number of atoms by the deficiency in electrons. And now we'll move on to the conclusion. There are a few potential sources of error when conducting these experiments. The first is imperfect measurements. I only measured with a basic ruler. The second are outside conditions, including humidity and the air itself, which can cause a change in charge. The final source of error is a loss of charge when handling the tape. And now for some following questions to conclude this lab report. What if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and the other charged objects? Nothing would change, as the same laws would apply. Opposites attract, and likes repel. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with hands or other objects? The tape's charge can be changed by coming into neutral objects like hands or the table. That is why it's important to touch them as little as possible, otherwise charges can move and affect the results of the experiment.